Hey everybody, Dr. A here, and in this video we're going to be providing some background information on force vectors directed along a line. So let's go to get started.
In this video, we're going to be discussing how to represent a force vector that's directed along a particular line. So basically what we're doing is we're representing some force vector, let's call it F, vector F, directed along some path from a point A to a different point B. Now, what we're doing here is nothing really brand new. It's just kind of mixing together and combining some of the topics we've learned in the previous few videos. So here's basically how we do it. Let's say that we have the following. Let's say we have a position vector RAB that is oriented from a point A to point B. Okay, so in this case, in 3 dimensions, we would have the following. We'd have RAB equals XB minus XAI plus YB minus YAJ plus ZB minus ZAK. And again, remember, if we're going from point A to point B, we can call that RAB, but when we're subtracting coordinates, we always say coordinates of the second point minus the coordinates of the first point, which is why we have the coordinates of B minus the coordinates of A. Remember, it's always when you say from point A to point B, it's second point minus first point. So this is our position vector. Okay. Now, what's the magnitude of this position vector? Well, we know that the magnitude of this position vector comes from the Pythagorean theorem, which also happens to be the distance formula. So, of course, as from our previous videos, we have xb minus xa squared plus yb minus ya squared plus zb minus za squared. All of that is inside of a square root, and that's the magnitude of that. So what we do then is we have this position vector from A to B. Then what we do is we define the unit vector from A to B. So again, we should remember how to do this. The unit vector from A to B is just going to be the position vector, RAB, divided by its magnitude. All right, no question about that. We've seen that in some previous videos as well. So then the last piece that we do is if we want a force, a vector force, to be directed along this, this line of action of this position, we say vector force F equals the magnitude of F times the unit vector of AB. Okay, and remember, we could write magnitude like this. We could also just write it as F. Remember our notation. You can write the magnitude without the vector hat and without the vertical bars around it. All right, so we could write this equivalently as F vector equals the magnitude of F times RAB divided by the magnitude RAB. And again, this is, coming from, this is the unit vector right here of AB, and I just kind of changed notations just to make sure you know that when you have F without the vector hat and without the bars, that means magnitude F, and same thing with RAB without the vector hat and without the bars, that means magnitude of the position vector AB. So that's pretty much it. We can piece that together, and then that's how we define a Cartesian vector F along a particular line of action or along a particular position from one point to another. So in the next couple of videos, we're going to have some examples that illustrate this.